for function number 8, we have fx equals to x cubic minus 3x squared. For step A, which would be getting out the restrictions and domain, we know by law that being this a polynomial function, we're going to have no restrictions and our domain would be x is an element of all real numbers. To get the x and y intercept coordinates, we have to isolate the x. So to get the x intercept, we have to do the function and equal it to 0. Squared equals to 0. And after that, we have to isolate the x's. So we'll work on it like this. And as we see, we have to work individually on each of these two factors. So this one would be x equals to 0, and this would be x equals to 3. And by law, we know that the y-intercept is going to be 0. So in the end, we get our x-intercepts, which are a 0, 0, and our y-intercept, the other x-intercept. So here we have our y and our x-intercept. Now we're going to try to find the symmetry of our function. Well, as we know, our function is fx equals to x cubic minus 3x squared. Well, how are we going to know the symmetry of our function? First of all, we're going to have to replace the number that we don't know, which would be the x here, for one number but in negative and positive sign. So we're going to choose in this particular case number 1. We're going to do f times 1 equals to 1 cubic minus 3 times 1 squared. This would be equal to minus 2. Now we're gonna work it with the negative sign. So f times minus 1 equals to minus 1 cubic minus 3 times minus 1 squared equals to minus 4. Well, what we can see here in our answers is that they might have the same sign, but they're not the same number. And we know it's not an even symmetric function, because in order to be even, you have to have the same number and the same sign. So we can see that we have the same sign, but we don't have the same number. So it's not even. And to be odd, you have to have the same number and different sign. In this case, we have the same sign and we have a different number, so it's not an odd function at all. Not odd. So as a conclusion, we know that this is not symmetric.
Find the letter D. We need to find the vertical asymptote, so we use the points 0 and 3, that is for the letter B. So we try to find the limits. So we need to put limit at x approaches to 3 for the function fx, that is x cubic minus 3x squared, and then we substitute the number x, the letter x, and is 3 cubic minus 3 plus 3x squared, and the result is 0 in this one. So now we use the other number, that is 0, the limit, x limit. We put the fx 3 cubic minus 3x squared. We substitute, and this equals 0. So we don't have vertical asymptote because we need to find infinite in this one. So we have finite numbers, so it's not vertical asymptote. We need to find the horizontal asymptote, so we need to find the limit again, but now we need to put x approaches to infinite, so we need to put fx equals to x x cubic minus 3x squared, and this one is gonna get infinite. So now we put another infinite, but this one we need to put minus infinite in this one. So x cubic minus 3. In this one we're gonna get minus infinite. So we don't have horizontal asymptote because we need to find finite numbers and we have infinite involved. In letter F, we need to find the derivative for this function. So we need, in this one we need to pass the 3 here, that is multiply the x, and the exponent is minus 1, so it's 2, and this one is the same. The 2 passes multiplied 3, so it's 6, x, and 2 minus 1 is 1, so it's like this.
We're going to use the derivative, the first one, to solve it. So we have at first derivative, this, and what we need is to make it equal to 0 and take common factor. So first, what we have in common is the x, so we take it out, and it's 3x, minus 6. And we just separate this to get 2 points. X equals 0, and it is going to be x equals 2. Okay? So now we make the ID test. For this we need a chart. We know that these 2 points are going to be useful to solve it. So we make x, and we need 2 points that are approaching to these numbers. So we're going to use minus 1. 0 is one of 4 points. 1, because it is also close to 0. And then we have over 2. These ones are important. And then we have number 3, that it is also close to 2. These are our critical points. So this is of the derivative, and we just replace the minus 1 in the x. So for example, if we have 3x to the square minus 6x, what we're going to use is 3 times minus 1 to the square minus 6 to minus 1. So we're going to have 3 times 1 minus 6 times minus 1. So it is 3 plus 6. Our answer is going to be positive, so we place a positive sign here. Now we replace the 0 with this one. It is all the same procedure, so we're going to have 0 always. Okay, so we're going to have 0 here too. And now with 1, it is the same. And we just replace it, and we're going to have a negative answer. And now with the 2, it is going to have 0 as a result, and also in this one. And in the 3, it is going to be a positive number, okay? So if we have positive, we know that it's going to go up, and negative, down, and again, up. Here, because we change our direction, is going to be our maximum. So x equals 0 is our maximum. And here, because we're changing again, is our minimum. X equals 2 is going to be. Letter H, what we're going to do is to take out the second derivative. So it is the same procedure. 2 times 3 equals 6, x to the 1, minus 6. And this is our second derivative. We have our second derivative. We need to take out the concavity test. First, we have to factorize to get the point that it is going to be important. So we take out the 6 minus 1 equals 0. So you just don't take and count this. And x, it is going to be equal to 1. Okay? So now we make the chart. X, and we, instead of placing the first derivative, we're going to place the second one. And 1 is an important point. So we place it. And now we have to take out two numbers that approach 1. So there is our 0 and 2. Okay? So it is the same as the ID test that you have to replace in the function, the 0. And what we're going to have here is a negative answer. And in the 1 is going to be 0. And in 2 is going to be positive. So what means that if we have a minus? It means that the concavity is going to go downwards. Here is nothing, and here is going to be upwards. We have two first sign or points that it is going to be 0, 0, point A and 3, 0, point B. And now we use our charts that they are here. So if we have 0 and 2, we know that it's going to go from minus to the maximum that is 0. So we start here, taking in count also the concavity. And we just continue, and we know that in the 2, it changes again because it is our minimum. So it is going to go upwards and touch the 3 and go. Because it is a polynomial function, the range is that y belongs to all the real numbers and the domain too. And that's it.